are still changing fractions into decimals and vice versa. So here we go. What do you know about 1.3? What fraction would that be?
13 over 10 over 20.
13 over 10. Now, can we also say 1 3/10? Yeah, but you know what? That's a huge grade school thing, mixed numbers. Really, we don't do mixed numbers, we just write in proper fractions. So 13/10. How about 0.4 repeating?
4 over 9.
4 over 9. Now, how many of you know that rule? That when it's a repeating, it's over 9? If it's one place repeating, it's over 9? I want to show you something, though, that a kid, a student, showed me a long, long time ago. She said, okay, we have, it wasn't this number, but she said, Mrs. Ford, we know that 0.3 repeating is 1/3. Would you agree with that? And we know that 0.6 repeating is 2/3?
Yeah.
So what's 0.9 repeating then?
1/3.
1/3. Isn't that awesome? She showed that to me. That is so cool. 4 9s. If you divide 4 by 9, what happens is you get that repeating decimal. So there is math behind that little rule, but if you haven't memorized, so 0.6 would be 6 9ths repeating, and 0.7 repeating is 7 9ths, and so on. Root 3 over 2, can you write that as a decimal? Well,
Yeah.
you can if you type it in on your calculator, but it will not be repeating and it will not be terminating. It's going to go on because root 3 is an irrational number. Ooh, 0.24 repeating. What do you think about that guy? Mr.
24 over
Matt?
99. 91.
It's
Go ahead.
24 over 81, right?
99.
Well, we can try it, we can see if that works. 24 divided by 81, you said that was your thought?
Yeah.
All right, let's try it. So let's do the division. Actually, let's cheat, let's do it on our calculator. So 24 divided by 81 is, it's a nice repeating decimal, but it isn't 0.24 repeating, it's 0.296 repeating. What was your thought on that, Alex?
Well, because you multiply by 9 to add an extra place.
Ah, okay, let's back up. You're thinking great, but let's back up a minute. So when if we had plain 0.4, that would be 4 over 10, right? So when we had repeating 4s, that ended up being 4 over 9. So Alex, if we have plain 24, plain 0.24, that would be 24 over 100?
Yeah.
So what do you think repeating 0.24 will be? 24 over 99. Try that one on your calculator. What's 24 divided by 99? That's going to be your repeating. Now, got to reduce it, of course. So that, what's that reduced by? 8 33rds. So the fraction for repeating 0.24 starts out as 24 over 99, but then we can simplify. What do you think 0.123 repeating would be? 123 over 999, and then reduced, of course. But yeah. Perfect. Number 6, properties of exponents. guys know these, you learn them every year. What's the first one? X to the nth times x to the nth is gonna be x to the m plus n, beautiful, love it. How about x to the nth divided by x to the nth?
X minus
M minus n. How about x to the mth to the nth? And then, beautiful. How about x to the 0? 1. You know there's math behind that, right? That's not just some made-up rule. Think about it for a second. If you had a division problem, and you had x to the mth divided by x to the nth, what does the rule for division tell you to do? Subtract. So wouldn't that be x to the 0? But we know that anything divided by itself is 1. Yep. How about x to the negative nth?
1 over x.
1 over x to the nth. Very, very good. So now, we gotta use the properties. What do you think about 3x to the negative second? 3 over x squared. Love it. The 3 does not move because it doesn't have the exponent, right? Great. What about the next one now, though?
1 over 3x squared.
That one will be 1 over 3x squared. Well, no, which is 1 over 9x squared, yep. Now, you don't need to put in any intermediate steps. I did, just so people could follow along. Did I turn this on, Kellen? Yeah, I did, good. Okay, 5 halves cubed, all right? What's 5 halves cubed?
125 over 8. 1 over 9. How might be an 8?
125 over 8, I heard?
Yeah.
Do we have a vote of confidence there?
Yeah.
Okay, what about negative 2/3 squared?
Negative 4 over 9.
Beautiful, negative 4 over 9. Why doesn't the negative go away? It's not in the parentheses, it's not getting squared. Very, very good. Okay, now we got a big. There is a lot going on in this problem. A lot. Many things need to be done, and the order they're done doesn't really make any difference. So what would you like to do first? How would you like to start the problem?
Square everything.
Square everything? All right, we can do that. So we would have what on top?
4 x negative 8. Y6.
Everybody good with the top? And we get the same thing on the bottom, so we'll have
9x squared. Y negative 4.
perfect. Good so far? 4 and 9 don't cancel, so I'm gonna have 4 and 9. What's going on here?
Be x negative 6.
They're going down, right? But there's already 2 down there, so if there's 2 down there already, and I bring 8 more down, I'm gonna have x to the 10th down there. And then similarly, these guys are going up, but there's already 6 up there, so now there will be y to the 20th. Nice. All right, let's give F a shot. Work on F with your partner. We'll see what we can come up with.
Are we ready to left first?
Fred, you guys got it figured out?
So that just adds to be 112 twice or what is it?
Or when you get X there.
Do you care which water fountain you put the water bottle? I keep because it's some of it tastes awful.
The only one that's bad is the science hallway. And the history hallway because it's slow. History hallway goes crazy.
The Redo upstairs one, the Redo upstairs one is the bathroom.
The best one I just discovered is in Tech Theater.
Oh, so you're doing geeky passes?
Yeah. No, that is the okay, but like, I just know which one's the best one. I don't like.
Oh, you don't care?
No.
I do.
Oh, I got 2 over 49. Oh,
You just have to
because when you multiply x by 2, add
So it'd be 240, wait, maybe 2 y,
yeah, 2 y.
okay.
49x to the 7.
Thank you. Up here, it's y.
Alright, this is what I got. Anybody else get that? Anybody match that? No?
Oh, I forgot to reduce.
Okay, somebody's got a, I mean, I could have made a mistake. Let's walk through it. So when I flipped this guy, I flipped it and cubed it. So 7 cubed is 343 and then x cubed. And then 2 cubed, 8y cubed. How does that first fraction look? Is that okay?
Yeah.
Alright. Then this guy, I could have reduced for 14 and 8. I didn't. I like the 14 and 8. And then I brought my x's down and got x to the 4th. I took 6 to the top, 4 to the bottom, and I had y squared. How does that fraction look? You might have reduced that, and it's okay if you did. Okay? So then it's a multiplication problem. So I said, okay, I got an 8 up here and an 8 down here. I'm just going to cancel them out. This is 2 times 7. This is 7 times 7 times 7. So I canceled out a 7 and ended up with a 2 up there and a 49 down here. So now on top, I have 2 y to the 5th. And on the bottom, I have 49 x to the 7th. So what did I do that confuses you, or do I need to help you figure out where you made a mistake?
I just forgot to reduce, but I got the same thing.
Good. Are we all set? Anyone have a question to ask about that? Yeah,
You distributed the -3.
I flipped it first. I did it all in my head, but the negative is when you tip it upside down. So now I'm gonna have the 2y on the top,
Yeah.
and I need to cube it. So v cubed, y cubed.
So if you distributed first,
Then you would have 7 to the negative third, x to the negative third, 2 to the negative third, y to the negative third. So everything would be negative, and so everything to the top is gonna go to the bottom, and everything to the bottom is gonna go to the top. So it's easier for you just to flip the whole shebang at once, but you can certainly do it individually.
How did you get rid of the 8 and then the 343?
I did, this 8 canceled with that 8. This is a multiplication problem, so anything on the top cancels with anything on the bottom.
Yeah, I got it. Yeah. Well, me too. That's probably so confusing.
Okay? All right. So now we're gonna have somebody, some table, so you and your partner, come to the board and do number G, or letter G. So, before I pick someone, do I have a table of volunteers? That's always best if we have volunteers. Who will come up and do. You're coming with your partner, so you'll hash it out together. Here they go, love it, boys, get up there, come on. Use black marker.
Uh-oh.
I got
Show your work.
Wait, 1 6 1 6.
And since I make millions on my videos, like you guys are cutting the first. Everybody should be working on this. Because we gotta check these guys. You guys done already? Wow, you're awesome.
Some site.
What do we think? Thumbs up or thumbs down for the guys?
Flawless.
Up? Good work, man. You did a great job. Anybody have a question about this? You didn't get it? Don't know what's going on?
What's the X's? I think, what do you do with X's?
The X's, there's 4 of them on the top. These are the only X's in the problem.
Yeah.
So there's 4 of them on the top and 5 of them on the bottom. So if you think about X to the 4th, X to the 5th, when you start canceling,
That's actually a good
what's gonna happen? There's 1 left over on the bottom.
Okay. I never thought of that.
When in doubt, you can always write it out, guys. You can always write it out. Just remember that you should never have any negative exponents in your answer. So if you do the whole subtraction thing, you got -1, well, that's gotta move to the bottom. We're not gonna move that to the negative first. All good? Okay, open intervals and closed intervals. You guys talk about I know you did. What do you remember about interval notation last year? You remember the parentheses and the brackets?
Oh, yeah.
This is called an open interval. And so if you're on the number line, it would be graphed with open circles. This is a closed interval. So if you're on the number line, it would be graphed with closed in circles. All right, so when A says sketch -4, 5 on the number line, of course, you're gonna have a dot at -4 and a dot at 5. And because that one is a bracket, you'll close in the -4 and shade everything in between. There it is. Is this coming back to you from last year? Now, what about this? What are you gonna do with this one on the number line? Open circle at 6. And everything to the left. Very, very good. So this is just the calculus. Interval notation is calculus notation. So this is just the calculus way of writing x is less than 6, right? All the numbers less than 6. Okay, likewise, what would 7, what would C look like? Closed out at 7 and shaded everything to the
Right.
X is greater than or equal to 7. Okay, so I've already done B and C was X is greater than or equal to 7. I already did those two. For number 10, write as inequalities. I already did that. This is B and that's C. What would A be as an inequality? What's this as an inequality? -4 less than or equal to X less than 5. X is between -4 and 5, including -4. All right, write an interval notation. We have volunteer or team. Always you can come as a team, you never have to come by yourself. Anybody wanna come up and write down the intervals for 11A, B, and C? Thanks, guys.
I think there are lots. Yeah, there are lots. I think it can be better. So back up. Like if there's two separate spots on another line.
All right, let's take a look at what they got going here. What do you think? I completely am in agreement with this. It's awesome. Let's make sure we're all clear about a couple of points. Anytime you put an infinity in your problem, it will be okay. It'll be a parentheses. And make sure that when you write your two numbers, they are in order. They are in number line order. So in other words, you would never write this. That doesn't make any sense. On the number line, negative infinity is over here, so it's always gonna come first if you're permitted. These are perfect. Good on that? All right, so now we are going to scientific notation. Tell me, what are you talking about? What is scientific notation? I'm not interested in the definition, I just want you to make sure you know what that means. And it says express your answer in scientific notation. What's that look like?
You're like a number times 10 to the percent of the next one.
So give me an example.
1.6 times 10 to the negative 7.
Perfect. That's scientific notation, right? What are the rules, or what is the big rule about scientific notation? This guy right there has to be between 1 and 10, right? So in other words, there must be exactly one digit in front of the decimal point. Right? When you're done with your answer. Okay, so now we're gonna do some work with scientific notation. This is a multiplication problem. Would you agree with that? We're multiplying. Multiplication is commutative and associative, so we can change the order, we can change the grouping, it won't matter. So what if we start by multiplying those two together, since those are the numbers? What do I get when I multiply 1.6 times 9? 14.4. Now, I have 10 to the 7th times 10 to the 13th.
20, 10 to the 20.
10 to the 20. But we're not done, are we? We're right. We are correct to this point. But is this in proper scientific notation?
Yeah.
No. So I'm gonna have to move that and make it 1.44 times 10 to the something. Now, there are rules about which way you're moving the decimal point and all that. I can't ever remember that. I just know that these two numbers are equal to each other. I'm simply rewriting the number. So if I made the front half smaller, then I'm gonna have to make the back half bigger in order to keep the number balanced. If you can remember the right and left rules, that's great. As long as you come up with this answer, it's all good. All right, let's try B. All right. 11 divided by 3.4. 0.5. Well, that's gonna be problematic here in a minute. But let's take care of the tens now. Now, I gotta have everything on the top. I can't, there's no, like, I can't have it over 10 to the something. So I'm gonna have to take that guy to the top, and I'm gonna end up with 10 to the negative 11. I don't feel like I explained that very well. Does that make sense to you, that that's how it has to look like? When I write scientific notation, I can't have this. This isn't what it looks like. It all has to be a string. So that has to come up to the top, and that would make a total of 10 to the negative 11. Now, this isn't good, so I'm gonna have to move that and make it 5.0. Now, I made this part of the number bigger, so this part is going to have to get smaller. Does everyone understand that negative 12 is smaller than negative 11? Good? All right, try that last one on your own. It's a biggie. First step look okay? Is that what you guys got?
Yeah.
Okay, but don't stop there. We'll have to make this 3.04. And then that went smaller, so this is gonna have to go to 20. All good? All right, here we go. Let's get this done. What would the scientific notation for 14A be? 1.9 times 10 to the negative 4. 1.9, 10 to the negative 4. Yep,
I
got a
have
question?
a question on C, or 13C.
Yeah?
And so, I guess I don't understand how we got the 10 to the 20th. Like, I thought whenever you had a
Okay, wait,
negative,
did you get 10 to the 19th?
I got 10 to the 17th.
No,
I got
but
10
I
to
mean,
the
did you get this right? For your first step?
Well, the first step we did was we multiplied those.
Yeah.
Wait, what?
Okay, so you have 12 and 4, that makes 16,
Yeah.
and then these will come out. So that'll be 19.
Oh, we didn't do that yet. I was just talking about.
So that would be the beginning. Okay, so multiply these and divide. I got 30.4.
Oh.
And then these get added, and this one actually gets added too, because you can subtract it, minus the negative 3, it becomes an add.
I think we were
So we're
trying to
doing
get
the
the,
same thing.
the whole top part before we did anything with the division.
But it shouldn't matter, because I don't know what the numbers are. The numbers should work out to be 30.4 in the end.
Okay.
But if you do 10 to the 12 times 10 to the 4th, that's gonna be 10 to the 16. Over 10 to the negative 3rd is gonna be 10 to the 19th.
Okay.
Okay? Now, this can't be, so I have to move it one place.
Yeah.
These must be equal. If this half got smaller, this half's gotta be bigger,
That makes sense. Okay.
okay?
Yeah.
All right, what about B, guys? I heard it here, what is B? 3.61 times 10 to the 7? C, what would that number look like if we wrote it out? 5940, or 5,940? And what about the last one?
0.0059.
0.0059. due on Tuesday. Let's go ahead and get started on, and you can always turn it in early. Always, you can turn it in early, don't worry about that. Let's get these labeled right away before we're out of time. What do we call this point right here? Call it the origin. At least for now. Later on, we're going to move to a different coordinate system and we'll have a different name for it. What do we call this right here?
X-axis.
I think somebody said Y. X-axis. This is the X-axis. And this one is the
Y-axis.
Y-axis. Perfect. These four sections of the Cartesian coordinate plane, and that's what this is called, the Cartesian coordinate plane, Rene Descartes. These four sections are called quadrants.
Yeah.
Here's quadrant 1, 2, 3, and 4. Where would the point 3, -2 be plotted? So 3, -2 is right here. There's point A. 1, -1.
40.
It is also, here's B. 0, 3.
Y-axis.
Y-axis, and -2, 2. Quadrant 2. This is all right, I think we'll stop there. Yeah, it's a good place to stop. So your homework is due on Tuesday. You are going to grammar your math league night, right? Get signed up next week. Just P1. No, just homework P1. Just homework P1. We'll pick up and continue P2. But homework P1.